Alright, in this problem, an electron accelerated through a potential difference 500 volt, then injected in a uniform magnetic field B, which is basically into the screen. Once in the magnetic field, it's complete a half revolution in 2 nanoseconds. Then we have to find out the strength of this magnetic field and what is the radius of this orbit of the electron. Fine. To solve this problem, we have to use the idea, basically the idea of the force, which is going to be that minimize that 1. So this is the force, the magnetic force must be going to the magnitude, you can say, I should say this is with the magnitude of this magnetic force must be equal to the centripetal force Fc. So since it's making a circular, it will make a circular, half circular into this magnetic field. So that's why we can say there will be force towards the center, that will be the centripetal force. These two forces must be going to be equal inside that magnetic field. Find that centripetal force Fc we can find out mass v square over r, the radius we are going to find out in the question number B. This is the magnitude of that centripetal force, and the magnetic force, which is the magnitude we can find out, this is that charge. B is the speed of that charge particle, strength of the magnetic field, and that sine theta. Theta is the angle between that velocity vector and the v vector. We can also express this one in terms of vector. Basically, we'll write, say, Fm. Sorry, I forget to write the subscription. Fm must be equal to the q into v cross b. Fine. Now that's mean I have to know that what is the speed of the electron when it is injected into that magnetic field over here. So what would be that speed of that electron over here? So I'm talking about this is the speed of the final, because that start from that point, which is that initial velocity, and you start from the rest. After traveling that this distance, which is the potential difference, actually that del V is the 500 volt, it's gained some energy. Due to that energy, it has some kinetic energy. So because we can find out that energy over here, right, using the energy conservation law. So what would be that law? I can write that the total energy initial must be equal to total energy the final. What at the total energy? I can say that kinetic energy initial plus that potential energy initial must be the kinetic energy of the final plus the potential energy of the final. So the kinetic energy initial we can write, so half of m vi square, plus the potential energy initial I can write q is the charge into electric potential. So that's a vi must be the kinetic energy final is going to half of m vv square, plus the potential energy final I could write on the capital QVF, which is the final potential. This is actually the speed, the small v actually they denote the speed of that electron, and the capital V actually denote the electric potential. Now this kinetic energy initial is the 0 because it start from the rest. Then I can find out, say, half of m v square plus q into vf potential minus vi potential equal to the 0. Or I can write down this one basically half of m v square plus q into del V, because this is actually the change of the electric potential, right? So this one actually the change of electric potential del V. Fine. Then I can also write down this is would be, since we are using that the charge is negative, since it's for the electron, so I can use that negative sign. This with the Q into del V must be equal to the 0. Then I can find out what would be the speed of that charged particle. Vf would be basically that twice Q into del V divided by m into root over. If you do that, put up this value, you can find out that the speed of the charged particle. So if I put 2 into charge is 1.6 into 10 to the minus 19 into del V, the change of the potential is the 500 volt, divided by mass of this electron, which is 9.11 into 10 to the minus 31 kg. If you do that, you will find out that the speed of that electron would be 1.33 into 10 to the power 7 meter per second. So this is actually the speed of the electron. So I can write, so this is actually the V. Instead of Vf, I am using that V over here. Fine. Say force, I'm choosing, say, the reference axis over here. I have to use that one, right? So this is my x direction, this is my y direction, and say the out of the screen is the positive, the k direction. If it is the case, then I can say the V, in terms of vector, the V, the speed of the electron, actually that 1.33 into 10 to the power 7 I hat meter per second, right? So this is that speed of the electron, and the magnetic field, which would be, I have to find out that one, which would be the minus B into k hat, right? Because the magnetic field over here is basically into the space, so that says with a minus k hat. Fine. Then to find out that magnetic field strength, what I'm going to do, I'm going to do that the magnitude of these two K's, actually I can write, say that Fm must be equal to that Fc, which is actually Fm, I can write Q into B into B sine theta must be equal to that mv square over r. I write down the magnitude. Now the angle theta is between that velocity vector and that magnetic field vector. So we find out that velocity vector is towards that direction, which is the direction of the V, and the magnetic field is basically into the space, right, in that direction. This is actually the strength of the magnetic field, which is basically into the space. Then the angle between these two vectors actually the 90 degree. Then we can write down K Q V would be basically mv square over r, right? So then I can find out that strength of this magnetic field from there, which would be B would be, we can write from there, B would be m mass into velocity divided by r into q. Now over here we don't know the r, that we have to also find out in the second part, right? Now first I'm going to find out that strength of this magnetic field, but there is a relation. We know that linear velocity with the angular velocity, basically it will be actually that omega r, right? And this omega also can be written as actually that twice pi f into r. I'm going to replace that v over here, then these should be the cancel out. What I will find out m into, instead of v I'm going to write in the 2 pi f into r divided by r into q. This r will be the cancel out from there. Then I'll find out this b is going to be that twice pi m into f divided by q. Now the mass, m is the mass of the electron and q is the charge. And what is the f? It's the frequency. Frequency we can find out, which is actually the 1 over t, inverse of the time period. But in the question they given, this electron create this semicircle or half circle in 2.0 nanosecond, half revolution. So that's mean this t we can write down 1 over 2 into 10 to the minus 9 nanosecond, because t is the complete time basically. So you find out in that form. If you do that, then you will find out that the frequency would be 2.5 into 10 to the power 8 hertz. Fine. Now if I put all the information over there, I can find out. So 2 pi mass of the electron is 9.11 into 10 to the power minus 31, and the frequency is 2.5 into 10 to the power 8 hertz divided by the charge of the electron, which is 1.6 into 10 to the power minus 19 coulomb. If you do that, then you will find out that strength of this magnetic field would be 8.94 into 10 to the power 3 Tesla, or you can say that 8.94 millitesla. So this is actually the strength of this magnetic field. Fine. Now what about the second one? The radius of this semicircle of the electron, that we can find out also using that formula over here we write down. So from this one we can also find out that radius, because we know that the magnetic field, right? Then we can find out that B actually m into V divided by Q into R, or we can write down the R would be m into V divided by Q into B. M is, if you put that mass of the electron is speed of the electron charge and the strength of the magnetic field, you will find out the radius of this semicircle would be 8.47 into 10 to the minus 3 meter, or you can say that the radius of this electron would be 8.5 millimeter. This is the answer of that second question. Fine. Thank you very much.